Okay, so that was about 8 minutes. How many of you guys are not done yet? Because I got like about 2 yeses in the chat. Okay, let's get started then. So let's start with number 1. So it says to solve for 3x plus 2 equals 17, and it asks you what x is. So who wants to try to do this one? Anyone? Aiden.
Yeah, so this is pretty simple. You just try to make it even. So you do stuff on both sides. So let's not do x first, just sort of 2. So minus 2 on both sides to make it so 3x equals 15 to it's still balanced, by the way, since you just took on both sides. Now, since 15 is just
You just subtracted 2 from both sides, right?
Yep, subtracted 2 from both sides.
And then you just divide both sides by 3 and you get 5. Cool.
Yeah.
Okay. So who wants to do number 2? I'm gonna draw a grid so you guys can annotate. Each mark represents 1. Who wants to annotate and try graphing 2x minus 2, y equals 2x minus 2? Remember, this is x and this is y. Anyone want to try that? No one. How about you, Matthew?
Okay, so if x equals 0, then y equals -2.
Yeah, so do you know how to annotate?
Yeah, I think so.
Okay, sure. So can you annotate it for us?
Is it here?
Yeah, and then?
And then if x equals 1, then it's over here.
No, actually 1 is positive. 1 is on the right side, okay?
Oh.
That's -1 though, okay?
Oh, shit.
Remember, 1 is positive, it goes right. If it's positive, up. If y is positive, okay, try it again. So where do you think y is when x equals 1?
Y is...
When x equals 1, let's plug it in into this equation. Plug it in into this equation. What do you get for y?
Y is 0.
Exactly. So where do you think that is? Yeah, it's right here. Okay, so then you just draw this line. Got it? Got it, everyone? That is what y equals 2x minus 2 looks like. Does that make sense to everyone? Yes? No? Okay, so who wants to try number 3? Samuel, do you want to try graphing y plus 3x equals 2y plus 2x?
Okay. I haven't got to number 3 yet, but I can try.
Oh yeah, you can try, yeah, for sure. So any initial ideas? Like seeing this complicated form, what do you want to do? Does anyone else have any ideas? Mary.
Because it's so complicated and it's not in the standard form where we can currently easily graph it, then we should simplify the equation first. And in order to do that, we can subtract 3x from both sides and 2y from both sides.
Exactly. Okay. Did everyone hear that? Mary is exactly right. So once we subtract 3x from both sides, we'll do a little subtraction. And we get y plus 0 equals 2y minus x. And then she said subtract 2y from both sides. And then we get negative x equals negative y. Does that make sense, everyone? That's just y equals x. Makes sense to everyone? Y equals x is just this line. Poof. Okay, so whatever x is, y is equal to that. So, for example, it'll pass through the points 0, 0, because when x is 0, y will equal 0. When x is 1, y will equal 1. When x is 2, y will equal 2, because y equals x. Does that make sense to everyone? Good? Okay, let's move on. So the last question asks you, what is the slope of the line 3x plus 4y equals 12? Daniel, do you want to try this?
I don't understand the problem.
Okay, yeah. So the slope, let me explain it. Okay, so when you're given a line, the slope of the line, let me use a different color, is how much it changes in height, that's in red, divided by how much it changes in width. Okay, so it's going to be, people like to write it like this. It's rise, it's how much it changes in height, that's how much it rises or goes down, divided by run, which is how much it runs from left to right. Okay. So what that means is, for example, if the line passes through the points 0, 0, and 2, 1, what do you think the slope would be? I can draw that line actually. Daniel? So it passes through 0, 0, and 2, 1. This is what the line looks like. What do you think the rise and run are? And since the slope of the line is the same for the entire line,
The rise is it says like this. The first one is here, so it's 1, and then this is here, so it's 2.
yeah, so exactly, that's exactly right. Okay, but you'll also notice, hey, it passes through the points 4, 2 as well. So why can't I use that point to find the slope? And the answer is you can, right? So let's try that with 4, 2 and 0, 0. Okay, so how you do that is you find the difference in the x values. That will be how much it changes left to right. So that will be the denominator. So what's the change in the x values, Daniel? So this x value to that x value. Whoops, that x value. What distance is this?
That is 4.
Yes. So you take the difference of the x values. 4 minus 0 is 4. And what's the difference in the y values? Oh, Jerry's here. Cool.
It's 2, so it's still 1/2.
Yeah. So do you guys see how the slope stays the same even when we use different pairs of points to calculate the slope? Does that make sense now, Daniel?
Yes.
Okay, so you might be wondering why I'm saying that, right? But I'll explain it in just a little bit, okay? So that's the slope of the line. And then when you're given an equation for a line, you can actually find the slope of the line from the equation itself. And let me show you guys how to do that. If you're given a line y equals mx plus b, okay? So this is the equation of the line. What do you think the y-intercept is? We talked about this on Monday, I think. The y-intercept, keep in mind, is when the line intercepts the y-axis. So that's when x equals 0, right? Because you're traveling 0 to the right, 0 to the left. So when x is 0, this term is clearly 0. We use a different color. Does that make sense so far, Daniel?
Yeah.
This term is 0. So when x is 0, y will be b. So every equation of this form, of that shape, has a y-intercept of 0, b. Okay, so just that's a fun fact for you to know. But the slope is how much y changes given a change in x. Okay, So let's use 2 points, okay? Let's use when x equals 0 and when x equals 1. Does that make sense? Can we use those 2 points?
Yeah.
Okay, so what point is it when x equals 0? When x equals 0, what does y equal? Remember, this is a y-intercept.
When x equals 0,
Yeah, so just plug in
y equals b.
Exactly, okay? Now, what about when x equals 1?
Then it equals m plus b.
Exactly, okay? So that's perfect. So what do you think the slope is? So remember, I said that the slope is the change in y values, change in y, right? Y divided by change in x. Does that make sense? Does that make sense to you, Daniel?
Yeah.
Because it's how much it changes in height divided by how much it changes in length or width. Okay, so what do you think the change in y value is?
Mean the one in the fourth problem?
Yeah. No. In this example, what is the change in y values? Let's use algebra first. Let's use variables first. So this is a first y value. This is a second y value. What is the change in y values? Like, what is the difference? Huh?
M.
Yes, because it's m plus b, right? Minus b. So it's just m in the numerator. Okay, so what about the denominator? How much does it change left and right?
One.
This one. Yeah, right. So it's 1 minus 0. Okay. So m over 1 is a slope. Does that make sense?
Yeah.
Okay. So now, how do you think we can find the slope for this question? Because it's not in this form, right? It's not in this shape. Like normally we can only find the slope if it's in the form y equals 4x plus 2. For example, this line, what is the slope? Mary?
4.
Okay, so what about this equation? I think you were raising your hand for this equation.
Yeah, so for this equation, we can do the same thing we did as in problem 3 and simplify or rearrange the equation.
Exactly, okay. So what do you think we can do?
Okay, so to get it into standard form, first we subtract 3x from both sides, and then we divide both sides by 4.
So we have 4y equals negative 3x plus 12. When we divide both sides by 4, we have 4y equals negative 3/4 x plus 3, right? So this is our equation, and this is called slope-intercept form. So keep that in mind. Well, that's a little messy. Okay. Oh, Rainy joined the waiting room. Okay, so who can tell me what is the slope of this line? Jerry. If you're there, what is the slope of this line? Or anyone else? Jerry? Mary.
Negative 3/4.
Yeah, exactly. Okay, so it's just this term in the middle. It's just, this is what we call m, this is what we call the slope, okay? So if anyone has any questions, now is the time to ask it because we'll be moving on to a new topic. Any questions about slope graphing? Okay, so by the way, in general for graphing, what you can do to start out is you can just plug in a couple of points. For example, number 2, y equals 2x minus 2, right? You can plug in when y equals 0, you can see that y equals 2 times 0 minus 2. Y is just negative 2. So it'll pass through the points 0, negative 2, right? When x is 1, you can just plug in 1, right? You will have y equals 2 times 1 minus 2, which is just 0. So then you have 1 comma 0. You can also plug in when x equals negative 1, right? You will have, when x equals negative 1, you'll have y equals negative 2 minus 2. So that's negative 1, negative 4. And when you connect those lines, you have 0, negative 2. 1, comma 0, negative 1, comma negative 4. And so the line looks something like this. Okay, so this is our equation, y equals 2x minus 2. So that's just how I like to start out with graphing. Once you get more familiar with it, then, once you find out, oh, what is a slope? Once you find out what is a y-intercept, it'll be a lot easier to start graphing. But for now, you guys can just start out by plugging in some points. Okay, so let me move on to what we'll be learning today. Today we'll be learning about something called a system of linear equations, okay? So when you have two or more equations, then you can solve those. You can solve for those equations to find two variables, okay? For example, what I mean by a system of equations is when you have two or more equations together. When you have three equations, for example, that's a system of three equations. When you have one equation, that's not really a system because you don't have enough, right? So in general, if you have one variable, you only need one equation to solve it. For example, you have x plus 5 equals 9. You can easily solve for x. You only have one variable, you have one equation. You just subtract 5 from both sides, x equals 4. That's how you solve those single variable, single equation problems. But if you have two variables, you need two equations to solve it. For example, if you have x plus y equals 5, and you only have that equation, you won't be able to solve for x or y. So as I said, if you have two variables, you need two equations. Three variables, you need three equations. And in general, if you have n variables, you need n equations to solve for those n variables. So let's start out by learning one of the methods to solve these equations. Okay, so the first method we have is substitution. And just like it sounds, you're going to be substituting some value in to find the values of x and y, okay? If those are the two variables you're looking for. So your two equations here, let me highlight them in red. You'll have x equals 5 and x plus y equals 6. So who can tell me what x is equal to, just right off the bat?
5.
Wow, very good. Okay, so x is equal to 5. What about y? How do we solve for y?
1.
1.
Correct. Wow, I got 3 ones. Okay, so the reason that it's 1 is because you substitute the 5 in for the x. So you have 5 plus y equals 6. And you can easily tell y is 1. So this is our answer for number 1, okay? But substitution isn't always this easy, okay? It gets a little harder. It gets a little more hairy. And we'll cover those cases as well. So as I said, in substitution, we plug in a known value into an equation to solve for the unknown values. In this example, you have x plus y equals 2 and x plus 2y equals 3. And you might be wondering, how do we substitute our variables in? In this case, you're not substituting in one variable. I'll show you guys how to do this one. And for the next questions, you guys can try doing them yourself, okay? So you have x plus y equals 2 for the first equation. And for the second equation, we'll actually rewrite this. We'll have x plus y equals 3. So who sees what we can do from here?
Well, we can subtract x plus y from the left side, and then we can subtract 2 on the right side.
Yes, so that is actually similar to elimination, which we'll be learning in just a little bit. But a more straightforward way would be to say, we can put this first x plus y in parentheses. That's called the associative property, by the way, because you can group terms differently. You'll have 1 plus 2 in parentheses. Let me write it out. This is the associative property. 1 plus 2 plus 3 is equal to 1 plus parentheses 2 plus 3. Okay. Basically, associative property says that when you're adding or multiplying, no matter how you group the terms, you'll get the same answer. It doesn't matter how you'll group the terms. You'll always end up with the same thing. Okay. So we can group it this way. And then we know that x plus y is equal to 2. So I'll write 2 plus y equals 3. And we can easily see that y equals 1, okay? So what can we do from here? Any ideas? Mary?
We can substitute the y value into the first equation to find x.
Yes, so I drew a long line. We're going to substitute it in x plus 1 equals 2. And so you can easily see x equals 1. So this is your answer, 1 comma 1. Let me put a box around it. That's our answer. So x equals 1, y equals 1. And remember, after you solve for these systems of equations, you always want to check, okay? You want to make sure, does x equals 1, y equals 1 satisfy these two equations? When x equals 1 and y equals 1, x plus y equals 2, so the first equation is satisfied. X plus 2 is equal to 3, right? So the second equation is satisfied. Once you check those two, then you're done, okay? If you're given two unique equations, you will always have one unique solution for two variables, okay? So we can look at that by graphing. If you're given a graph, we can actually graph this first one, x plus y equals 2. Does anyone want to try graphing that? Mary?
I just annotate, correct?
Yeah.
Okay.
And each tick mark represents one square, I guess. One unit.
Okay.
Correct. Okay, so that's what the first equation looks like. Is that the first equation?
Yes.
Yeah, okay. So yeah, it's correct. Okay, so when y equals 0, let me use a different color. I'm going to use yellow. Okay, when x equals 0, y equals 2. X equals 1, y equals 1. X equals 2, y equals 0. Okay, so it looks like that. So it is correct. Okay, so let's have someone else graph the second equation. How about you, Matthew? You haven't spoken in a while.
Okay.
So the second equation, you have x plus 2y equals 3. And you can actually rearrange that if you 2y equals negative x plus 3, right? And you have y equals negative 1/2 x plus 3 over 2.
Okay.
So tell me some points that it passes through.
So it passes through over here.
I'll use green for this equation. Okay, just verbally tell me what points it passes through. Okay, so
Okay. So it passes through negative. If y equals 0, then it passes through negative 3/4.
I'm sorry, what? Y equals 0. Okay, so you have 0 equals, tell me what to write.
0 equals y. If 0 equals y, then
0 equals, then
then we can like
Remember, y is equal to this thing, okay? So how do we solve for the right? Okay, so you don't do it that way, okay? You want to plug in x and then find the values of y in general, unless you see that plugging in y will give you very simple, elegant solutions for y, okay? So try plugging it in for x. Hello? Are you there? Lagging?
Yeah, I'm here.
Okay, so which values of x do you want to plug in? Hello?
Oh, I want to put in
Look, you plugged in 0 for y. Why don't you plug in 0 for x too? Okay, so
okay.
that's our first point.
So if
What about our second point? Okay, what's another point that we can plug in? That'll give you an easy solution.
we can also plug in
Oh, look, Anthony.
if x is just 0.
That's what we just did. Look, this point. When x equals 0, y equals 3 over 2, right? Because when x equals 0, this term goes away, and it's y equals 3 over 2. So tell me, what does y equal when x equals 1?
Y equals 1.
So what does the line look like? It looks like this, okay? You can see that these two lines intersect at 1, 1. Okay, so that's what the solution to the equation is. Got it, everyone? Make sense? So that's one way to solve for these equations. You can graph. Wherever the two graphs intersect, in this case, they intersected at 1, 1, then that's the solution. So the solution is 1, 1. Okay, another example, 3x plus 2y equals 4, x plus 2y equals 3. Who wants to try this one? Aiden?
Yeah, so solve for x and y.
Yes.
For the second one, first one.
So as I said before, when you have two equations, you're solving for two variables, okay? Don't be given two equations and you're asked to solve one variable. So when you have two variables,
Okay.
you're solving for both equations. Solving both equations.
All right, let me see then.
You can take your time because I just put this question on the screen. But try to use substitution.
So
Yeah.
so it's 1.
Okay, let's start by labeling these equations, equation 1 and equation 2. Okay, so for equation 1, let me rewrite it to make it a little bit easier to visualize. Again, this is associative property, okay? So that's our first equation. And our second equation is x plus 2y equals 3. Aiden, so do you see anything in common for these two equations?
X plus 2y.
Exactly. So we can substitute that in, right? So what do you get when we substitute it?
Substitute. Well, it seems like x plus 2y equals 3, so x plus 2y equals 3 in the equation. So 2x must equal 0.5.
Exactly, okay? That's very good. X equals 0.5. Wow, Aiden, that's really good. Okay, so where do we go from here?
Go from here. Well, then we go back to the second equation. I mean, since x equals 0.5 or 1/2, that means you can do 3 minus 1/2, and then what's left is 2 1/2, I think, and divide that in 2. Divide that in 2, which equals like that's 1 1/4.
Exactly. Okay, so
Y equals 1 1/4.
5 over 4. So our answer is 1/2, comma 5 over 4. And if you plug that in to these two equations, okay, for the first equation, let's see what we get. We get 3 halves plus 5 halves equals 8 halves, which is equal to 4. So first equation is satisfied. Let's check the second equation. 1/2 plus 5 halves equals 6 halves, which is equal to 3. Okay, so that equation is satisfied. So those two equations are both satisfied when we have 1/2 5/4. That's what solving the equation means. We want to satisfy both equations simultaneously. Next example. Actually, I think we're going to be learning about elimination now. Let's skip this one. Let's learn elimination first, and then we can go back and solve that if we have extra time. So in elimination, we're going to be subtracting or adding equations in order to eliminate some of the variables. And let me show you guys an example. When you have negative x minus y equals 2 and x plus 2y equals 3, then you can just add these equations, okay? So you add the left-hand side and you add the right-hand side. And the reason why that works is if you have two equations that are both satisfied, for example, you have 5 equals 5 and you have 6 equals 6, right? When you add those two together, you add the left-hand side, you add the right-hand side. No matter what, the left-hand side and right-hand side are still going to be equal after you add them. So we can do that with variables too, because variables are just numbers as well. So when we do that with variables, you have negative x minus y equals 2, x plus 2y equals 3. You're going to add the left-hand side and you're going to add the right-hand side. On the left-hand side, you have x minus x plus 2y minus y equals 3, equals 3 plus 2, okay? Then you have these two cancel out, and one of the y's cancels out, so it becomes y equals 5. And then you go back and substitute that into the first equation. You can have y negative x minus 5 equals 2. So x is just equal to negative 7. Make sense to everyone? If you plug that into the first equation, you get 7 minus 5 equals 2. So the first equation is satisfied. Second equation, you get negative 7 plus 10 equals 3, also satisfied. Okay, so that's an example of elimination. So let's have you guys do some example questions as well. Now remember, instead of adding, you can also multiply. You can also subtract equations, okay? But in general, you don't want to multiply two left-hand sides to get two equations together. You would want to add or subtract a multiple. Let's try this one, okay? So you have 2x, you have 2x plus 4y equals 3. And then you have x plus y equals 2. Anthony, do you want to try solving this? Let's label this 1 and 2. So Anthony, whenever you're ready, whenever you have some sort of idea of how to solve this equation. Anthony, you there? Okay, Daniel?
You minus an x from the second equation, and then it's going to be x plus 4y equals 3, and then it becomes
Wait,
y equals 2. What?
Hold on. So remember, once you do something to the left side of the equation, you have to do the exact same thing to the right side. Okay, so if we subtract x from the left side of the equation, we have to subtract x from the right side. But also we can subtract entire equations, okay? So you got them confused a little. When you're manipulating two sides of the equation, you have to do the same thing to one side as you're doing to the other. When you're adding or subtracting equations, you have to make sure you have to add or subtract the whole thing. Does that make sense?
Yeah.
Yeah, so you wouldn't be able to subtract just x. You wouldn't be able to subtract just y either. So Aiden, do you want to give this a try?
Oh, what? You want me to solve this equation?
Yeah.
Okay, so now this is one y. Elimination, I don't know the equations to cancel out or eliminate some variables. So wait, so that's not negative? I thought no, actually, wait.
Yeah.
So wait,
instead of adding, we can also subtract.
have you multiplied what?
Instead of adding, we can also subtract equations. So just keep that in mind. I'm not saying you are definitely going to subtract in this case, but just keep that in mind.
I mean, this doesn't look like it may work. It doesn't seem like multiple subtract equation 1 from equation 2 doesn't seem like it makes sense.
Okay.
Or
Let's try someone else. Oh, Mary. Yes.
So since we look at this equation and we realize it won't help us even if we add or subtract them, then we have to modify them so we can use them properly. And for me, I think the simplest way to do that would be to multiply equation number 1 by 2. So you get 2x plus 2y equals 4.
2x plus 2y equals 4. Okay. And then what can we do from there?
And then when you subtract equation 1 from equation 2,
Uh-huh.
then the x variables cancel out and you get 3y equals 1.
Oh, I think my handwriting is a bit messy, but I think you're subtracting this way, right? So
Yeah, it would be 2y.
2y
Equals negative 1.
exactly, and then you have y equals negative 1/2. And then, like usual, I'm pretty sure you guys know this, just plug it into the first equation or the second equation, either one works. You will get something like 2x equals 5, something like that. Okay, but I think you guys all know how to do that. So let's move on to some other examples. Let's try to get this down. Let's try to get everyone to understand this before we move on to the next topic, okay? So let's try this system of equations. Jerry, do you want to try this?
Okay. So maybe you multiply the bottom one by 2.
Yes, exactly.
6x plus 4y equals 16. And then the x's cancel out. So then 1y is 13.
Okay, so make sure you're being consistent when you're adding or subtracting equations. Okay, so in this case, we're subtracting the bottom equation. We're subtracting the bottom from the top, okay? So it'll be 6 minus 6, 5 minus 4, 3 minus 16. Does that make sense? So make sure you're being consistent. You don't want to subtract the bottom from the top on the left-hand side and then subtract the top from the bottom on the right-hand side. Does that make sense? So then you have,
so it's negative 13?
yes, 5 minus 4y equals 3 minus 16. Y is equal to negative 13.
Yeah.
And now to solve for this, it's pretty straightforward. You just have 6x minus 5 times 13. I think that's 65 equals 3. 6x equals 68. 3x is equal to 34. And x is equal to 11 and 1/3, or 34 over 3. Okay, so that's how you solve this system of equations using elimination. Got it, everyone? Cool. Okay. So have any of you heard of quadratics before? Anyone? Mary. Okay, cool. So quadratic equations are basically equations where you have a variable raised to the second power. And before we said linear equations, they're raised to the first power, right? So x, let me draw x, whoops, x plus 5 equals y. This is linear. Okay, x plus 5 equals 9. This is linear. But something like y equals x squared, this is quadratic. X squared equals 37, that's quadratic. X squared equals 68, that's also quadratic. Okay, so that's because you see this little 2 over here, the little 2 on top. But when you have y equals 5 squared, this is not quadratic, this is linear. This is just equal to y equals 25. Keep this in mind because this is a constant value. You need a variable, not a constant, raised to the second power. Make sense to everyone? So now that we got what a quadratic equation is out of the way, we can start talking about why are quadratic equations useful. Does that make sense to everyone? Any questions about what is and what is not a quadratic equation? Okay, with that said, we'll be moving on. Okay, so in order to fully understand quadratics, we need to first learn
I have
what.
a question.
Huh?
Is it for only 2, not for 3 or 4 or 5 or 6?
Yeah, it's only for x squared, okay, or y squared. It's only to the power of 2. When you have to the power of 3, like x cubed, that's actually called something else. That's called a cubic equation. Or when you have 4, it's called a quartic equation, or a quintic equation if it's to the power of 5, okay? But those don't matter. The most common one is a quadratic. So with that said, let's talk about a little bit of factoring so we can learn about quadratics, okay? So in factoring, the basis of the factoring is the distributive property. When you have a plus b in parentheses multiplied by c, you can distribute that over. When I have AC and BC, I mean a times c plus b times c. And if you think about that, that should make sense. Let me try to come up with a visual example for you guys. Okay, so let's look at this example, 2 plus 3 times 4, okay? So let's imagine you have 4 crates. And in each crate you have 2 bags, okay? So you have a bag of 2 apples, a bag of 3 apples. 1, 2, 3, 1, 2. Bag of 2 apples, bag of 3 apples. Bag of 2 apples, bag of 3 apples. And then the last one is the same. In the bag of 2 apples, bag of 3 apples. So this is what 2 plus 3 times 4 represents. Because you have 5 apples in each crate, or 2 plus 3 apples in each crate, and then you have 4 crates total, right? So this is what, how do I say this? 2 plus 3 parentheses times 4 represents visually. Now, this one, based on this equation, can be written as 2 times 4 plus 3 times 4. Okay, so one way to visualize this is if we took all those apples out of the boxes, okay, and we split each of these bags into separate boxes. So then we have 4 small boxes for 2 apples each, and then 4 large boxes for 3 apples each. You just do dots, so you have 2 apples in each of the small boxes and 3 apples in each of the large boxes. And what I did here was I just took each small bag and put it in a small box. Took each large bag and put it in a large box. Does everyone understand the distributive property now? So what is this? What is this represented by? This is represented by 2 times 4. This is represented by 3 times 4. Does that make sense to everyone? And in the red, this one is represented by 2 plus 3 in parentheses times 4. And the number of apples didn't change. That's why 2 plus 3 times 4 is equal to 2 times 4 plus 3 times 4. Does that make sense to everyone? Yes, no, maybe? Any questions? Does anyone get what I said? Okay, cool. Okay, so we have one person nodding their head. That's good. Better than 0. So that's the distributive property. That's called distributive property of multiplication over addition, okay? But when you're factoring, we often don't deal with that sort of straightforward distributive property, you'll often have a plus b times c plus d. And how do we find what it equals? One way we can do this is to treat a plus b as one term. Okay, no, actually let's treat c plus d as one term. Let's call this term z. Okay, so we have a plus b times z. And remember, z is equal to c plus d. Z as in zebra, by the way. A plus b times z, based on this distributive property, is just a times z plus b times z. And now what is this equal to? We'll substitute c plus d for z, right? A times c plus d plus b times c plus d. And then using the just distributive property again, you have ac plus ad plus bc plus bd. Does that make sense to everyone? Does everyone see how we went from this left-hand side to this right-hand side? Please nod or shake your head if you don't understand. Okay, thank you, Mary, for the feedback. Yes, that's good. Okay, so one way to do this without thinking about it each time. So I see that we're running low on time. Let me just finish this and then I'll let you guys go. Okay, so one way to factor quickly is something called FOIL. FOIL stands for first, outer, inner, and last. Okay, so what that means is you multiply the first elements of each parentheses, then you multiply the outer ones, then you multiply the inner ones, then you multiply the last ones. Okay, so that's how you get AC plus AD plus inner is BC and last is BD. Okay, does that make sense to everyone? So that way you don't forget any terms. Make sense? So that's how you factor element. That's how you factor parentheses. Make sense? Yes? No? We'll do some more examples for your homework, and they won't be too hard because I know we didn't cover everything. So let's just I'll give you guys some simple homework questions on factoring.